I'm Anil Kumar, and in this video we will understand the concepts of equivalent linear systems. When we say equivalent linear system, that means systems which have the same solution or the point of intersection. Let us start with the given equation. We are given a linear system here where x plus y equals to 1 and 2x plus y equals to 4. Let us try to find the solution of this system. We'll do it graphically first. X plus y equals to 1 means a line where sum of x and y quadrants is 1, right? So one of them, if I put y as 0, I get x equals to 1. If I put x as 0, y-intercept will be 1. So I get these 2 points, right? So these are basically x and y-intercept. So we are trying to find x-intercept and y-intercept, right? And x-intercept is a point where y value is 0. So if I put y as 0, I get x equals to 1. And for y-intercept, I have to place x as 0. So I get y equals to 1, right? So I've taken a very simple equation because we are trying to understand a concept here, right? So we'll join these 2 points, which represents x and y intercepts of the first equation. So that is a part of our linear system. Now let's look into the second one. Now here, what is the x-intercept? Now for x-intercept, I have to place y as 0, right? So if I write y as 0, I get 2x equals to 4. X will be 4 divided by 2. That is to say x is 2. Now y-intercept will be x equals to 0. Then y equals to 4, correct? So these are the 2 points, 2 for x-intercept and 4 for y-intercept. So if I join these 2 points, then I get the second line, and that line is a part of our linear system. Here it is. Now these 2 lines intersect at a point, right? They are not parallel, so they will surely intersect. And the point of intersection is 3 minus 2. So what we get is point of intersection, right? And that point of intersection for us is 3 minus 2. So what we can say here is the solution of a linear system is, so what is the solution? Solution is 3 minus 2. That is what we've got. Now when we say linear systems and equivalent linear systems. So what is an equivalent linear system? So equivalent linear system is set of equations which will have the same solution, right? So when we say equivalent linear systems, we are looking for set of equations. I should say linear equations this time, linear equations with same solution, right? That is what we mean when we say equivalent linear system, right? Same solution. So in this case, our solution is 3 minus 2. So we have to find a set of linear system different from what we are given here, which will have same solution. How to find it? That's a big question. How to find it? And this is what we are going to answer in this video. So what we have here is, we have one equation which is x plus y equals to 1, and the other one is 2x plus y equals to 4. Now the technique is that you can add these equations, you can subtract these equations, or you can multiply one with some constant number and add. Doing all those operations will give you equivalent system. That's kind of tricky. Let us see how, and we'll verify. So what we will do is, let us say this equation is equation 1 and this is equation 2 for us. If I add these equations, what do I get? What I'm trying to do is, I'm adding equation 1 with equation 2. So if I add, I get 2x plus x as 3x, and y plus y as 2y, and 4 plus 1 as 5. Now when I add, I have to check if this point lies on this equation or not. If it lies, then this could form a linear system with the original one also, right? 3x value and minus 2 as the y value. If I write 3 here, 3 times 3 is 9 and minus 2 times 2 is minus 4. 9 minus 4 is 5. It works. Do you see that? So the point 3 minus 2 lies on this equation. Okay, so I got one of the different. This is very different from the original equation. Okay, now let me do this part. Subtract these two equations, 1 minus 2. Now if I do 1 minus 2, what do I get? I get minus x, y minus y is 0, and here I get minus 3. Or I can say x is equals to 3. Now, so I have a new linear system now, and this system has two equations. The equations for us are, let me call this equation 3 and this equation as equation 4. So, will they pass through the point 3 minus 2? If they do, both of them, then the point of intersection between these two linear equations, which are different from original, is the same as that of the original. So that forms a equivalent linear system. This graph x equals to 3. X equals to 3 means a vertical line through 3, right? As you can see, it goes through our point of intersection, correct? And the other equation is 3x plus 2y equals to 5. Now here we can find the x and y intercepts, but that gives us a very difficult value to deal with. So what we will do here is we will just check the point 3 minus 2. So if I write, so let me write 3 minus 2 in the second equation. That means 3 times 3, which is the x value, plus 2 times minus 2. What do I get? Do I get 5? 3 times 3 is 9, right? And minus 4 is indeed 5, correct? So this point lies on this equation, right? Similarly, we can find another point also on this equation. If I write x as 0, I get my y-intercept as 5 by 2, right? The y-intercept will be right. So if I have to find the y-intercept, I can put x equals to 0. Then I get 2y equals to 5, or y equals to 5 over 2. That means 2.5, correct? So 2.5 is a point here. Joining this with the point which we have already found, we can draw our new system. Now what we notice here is that whenever you form new equations by adding or subtracting original equations, you get equation for new lines. These two are two different lines, but key thing is they also intersect at the same point at which the original equation intersects, and therefore we say that this system, which means the system having equation 3x plus 2y equals to 5 and x equals to 3, forms a linear system which is equivalent to the given original linear system, right? One more thing you notice, that is, sometimes when we do all these additions and subtractions, you can get a very simple equation in one variable. The other equations you find in two variables, correct? So you get an equation x equals to 3. Sometimes when you do these additions and subtractions to form equivalent linear systems, you may get equations in single variable, right? In fact, the simplest set of equations which will be equivalent linear system for the given system will be what? Can you tell me? Will be x equals to 3 and y equals to minus 2. That is the simplest form of an equivalent linear system for the given system. X equals to 3 is the vertical line which we already have, and now I can sketch y equals to minus 2 for you, which will be this line, correct? as you can see, it also passes through the same point of intersection where the original linear system passes through, right? So what we learned here is that there could be many linear equations representing the same linear system, and these different equations may have different graphs, but all of them pass through one point, and therefore we say they are equivalent linear systems. I hope you learned a lot from here, right? So we'll do a true or false question based on what we have learned here, and then move forward in discovering more about equivalent linear systems. Thank you.